Hi everyone and welcome back. Welcome to my fourth video on the Node.js microservices world, where we are talking almost everything about microservices. So in the last videos we talked about baseline code, and then we were talking about the core agenda, what we are going to cover. So we are targeting these two stuff like Express with the Node.js, Express TypeScript with the Node.js, or nextjs with the Node.js. This is like a technology to build the services. But before that, I'm starting this playlist from ground zero, and a lot of people are expecting me to cover some basic stuff. But I already have a two major playlist primarily on the microservices, nextjs microservices, and simple microservices using Express. This is the third playlist which we are talking. So I will talk about some core aspects also, like what is a microservice. So when you talk about a simple service, how you define it? So let's say if I talk about simple service, so how you define it? It's like some backend server-side logic which you are executing to change the state of the data based on the client request or based on the request coming from another service. So there can be a service-to-service communication, right? Or service to client, or simply there is a client who is requesting you for some update, and then there is a service who is there to serve the request. Service to service is like a system to system, client to service. Let's say from Chrome there is a UI app that is making a XHR request, API request, and that is going to hit some request, either REST or GraphQL or SOAP based services, and updating the system state. That's a service, right? So that is the actual definition of service. Service is just a minimal or any server-side logic based on the request coming from another external service or internal service or from the client. Someone is triggering something to execute, and that is changing the state. Now, whoever is executing is authorized or not, that's a different topic. Now, this service can be anything. In our definition, when we talk about this type of services, what are these services in our logical world? This service is nothing but an interface. This service is, let's say, this service is running as a 24/7 HTTP server, right? So there is a physical server you have somewhere on the AWS and Azure that is exposing, that can expose lots of different interface, like SOAP based interface, which is web services. It's little legacy, but still people use it. Or RESTful based interface, where you can actually do HTTP get, put, post, right? Get, put, post, and update the state of the data. And or you can actually expose a GraphQL based interface, where you are going to do HTTP post with query and mutation. Or now there are other interfaces are also available with the protocols, gRPC, tRPC, or TCP based interface. So this also lies on HTTP protocol. The communication still happens on HTTP protocol, but these are the different interfaces, server-side logic which is executing. Now you can think about, okay, you have created an Express-based app which is exposing 5000 port, right, and running on some physical server whose IP is this, right? So it is exposing some either REST interface, GraphQL interface, or tRPC, gRPC interface. You can access that interface using a browser client or maybe another service client or something, right? So that is a service. Now that service, when that service will become a microservice, you might have done a simple Express Node.js app and hosted that on either Heroku, AWS, DigitalOcean, or somewhere. that is a service. But when that service will become microservice, that is an important point, right? So that we are going to talk about. Because when you build a complex systems, I'm not talking about, okay, simple, where you are just doing a simple user cred. Okay, user cred, you can just define a simple service doing a REST API, GraphQL interface, and providing you the create, insert, update, delete methods. Okay, now here we are talking about microservice. So what is a microservice by the definition? I mean, there are many definitions, but a simple definition is microservice is nothing but as known as microservice is nothing but a simple service which is independently deployable, loosely coupled, and organized around the business capabilities. Okay, there is a defined boundary for that service owned by a small team. So here I wanted to talk about this thing. I mean, I can build this whole system into a one single monolith service where I'm managing the orders, delivery, consumer service, tracking of the items, all those things. Or what I can do, I can create individual services which are doing only order, which are doing only delivery, which are doing only consumer service. And they know nothing about each other. They are completely independently deployable. There is a different teams are managing them. They are loosely coupled, means they don't know about anything. They can know based on the events. Let's say I send an order created event to the delivery, because now you need to prepare the delivery for that order. So they know nothing about each other. They understand the events coming from the individual services. They are totally loosely coupled. Okay, and they are exposing some interface to the client like REST, GraphQL, or maybe TRPC, gRPC, some specific interface. Now we are not stick to one set of technologies. Okay, you are just exposing REST. You can do GraphQL also, and then there is a client going to send query and mutation. Okay, so microservices in the Node.js world, first of all, they are deployable, and whatever they are doing, they should be capable enough to do that, and they should not have a shared database. That means delivery service has its own data, own database, order service has its own data, own database. There should be no dependency or coupling even for the data. There should be no sharing of data. I mean, there may be if there is a case, but when you know that delivery has nothing to do with ordering, I mean, the data can be segregated. Yes, they need to communicate by some means. That's a different thing. So that becomes a microservice, and microservices again nothing but a simple you can create a, when you are creating, because microservice word is a hype and people get often confused, you can just create a simple express REST APIs, express Node.js REST APIs deployed somewhere, which is just doing authentication. It is having auth logic, which will just validate your, okay, your username, password, or email password, and it will give you the access token, which has some expiry. So that can become an individual service, right? So once you get the access token, you can access your external APIs or internal APIs, and you can validate, okay, this token is valid through this service. So this can be a microservice because this can be independently deployable. It has nothing to do with any other service, not knowing other services. It's totally decoupled. And it has its own data storage. These are the primary things which you need to have when you are building a microservices for any complex system. Let's say if I'm building this urban clap, buying service online for the anything, for the electrician, for the carpenter, for plumber. I mean, these are the services which are available on the urban clap, and we are building the clone of it. Then I should be able to build a simple auth service, or either I'm using the auth 0 or external auth provider, but whatever I'm doing that service, that should be totally decoupled with the whole interface. It may be providing you the token, access token, that you can use to further authorized against the other service APIs, but it's deployable, not knowing other services. It may know, but it doesn't need to call or make any external API call. It should be totally decoupled. You can communicate through the events, but okay, you will not be making any external direct HTTP interface at HTTP calling, because we want this service to be totally decoupled. from other interface. Has its own user data, user preference data, and user settings, system settings. All those things you can store in this authentication app. So when it comes to designing or deploying these services, they should be totally independent container or independent service, independent ECS container or independent Lambda that does only authentication. Even for if you want to send an email, let's say I have this service that is doing authentication. Okay. Even if you want to send an email when user is successfully being created in the system, so here for the email, we might write a simple notification service or any kind of external interface. Not the authentication service won't be sending the email, because then you need a tracking. Okay, let's say I'm sending email, right? And the email delivery may also fail, right? So we may need a retry mechanism, and we need to track what all the email addresses where the email has not been sent. So it's altogether an external service which requires all these logics. You may have some kind of a retry mechanism in this email service. So all those things are not part of authentication service. So that's why we need to create a decoupled email notification service or simple generic notification service which takes care of email notification, or maybe mobile messages, or all kind of external notifications, and they can also take care of retry and delivery mechanism. So that won't be a part of authentication service. So this is how we define the business boundaries, and this is how we create a decoupled service. Now authentication and email service are totally decoupled. Once user does the successful sign up, we can send an event. So this service knows only the event which needs to be sent when the sign up is successful, or when you created your account successfully, right? So that events needs to be handled by the email notification service. So this is the event handler service. Based on this event, they will send a notification to the defined email ID or a mobile number, right? So this is how you create a decoupled architecture or decoupled event-driven services. And these services can be created either just using simple Node.js Express TypeScript or nextjs TypeScript, that we are going to decide. Okay, so first of all, we will see how to create a tiny service which can expose a different kind of interface. So the interface can be simply REST, GraphQL, okay, gRPC, or tRPC. But these all are synchronous interface. That means when this service is sending, when there is a request coming, let's say I'm talking about this auth service, and this is a client. When the request is coming from this service to this authentication service, this is all purely synchronous, because you might be sending a request on HTTP protocol, right? Then you are expecting a response back immediately till the HTTP timeout happens, right? So you send a username password, authentication service will validate, and it will send you the response back. So this is synchronous, request and reply. This kind of service. But there may be a scenario like this, where we can send an email over the time, because email delivery doesn't need to be immediate. It can happen over the time. In that particular case, you will be dealing with the event driven system, or sending the event to a target service which can execute once the event is received in the target service, right? So for all those services, these are not synchronous, these are async services, and this is async communication. And for these kind of communications, you can use EMQP protocol, or you will be using all these event driven mechanism. You can use a Kafka to send an event or a RabbitMQ to send an event, and this email service in a loop will listening to that particular Kafka topic or a broker queue and will get the message, okay, I got this event and I will just process it. So this is not something which is exposing the HTTP interface, but this is because HTTP interface means it is going to take the request and send you the response back. And this authentication service can be built either using REST, GraphQL, gRPC, TRPC interface, or TCP. All will be synchronous, request and reply. You send a request and they need to respond back. So these are message driven, right? Because you send a request and reply, but these are fire and forget. You send a event, you don't even know where you are sending the event. You are just sending the event to some communication channel or messaging queue. There will be a reader, or you can say subscriber to that communication channel, like email service, which is asynchronously will read that event and then will process that. So this is asynchronous communication. You can say event driven communication. This is request and reply synchronous communication that happens right now. You need to respond, and there are different interfaces available. You can write in the RESTful, web services, SOAP based services, GraphQL, gRPC, TRPC, or a TCP based interface it can expose. Okay, so this is what the whole architecture and different architecture patterns evolves around all these things. The communication protocol, communication type, what is the interface is being exposed from the service. These are the services. This is the UI client browser. This is a service to service event driven communication. There will be a UI client sitting here doing authentication. Okay, I will do it like this because this is the same thing. So we are talking about this auth service here, right? You send a request from the UI client, and now auth will send an event to this email notification service. We can just put these arrows to here. This is the event which is going further like this. You can skip the arrows part. I don't want it to repeat the boxes again. Yeah, so let's talk about building these request and reply based services first, which are independently deployable, decoupled. You can talk about simple any microservice which we need to build this SaaS based platform. And then we will see how we can add these 12 factor principles to build an independent service. And then how we will achieve this decoupling between services.